Good morning, everyone, and thank you, Michael, for your presentation. My presentation showed the key aspects of the work done of an DDS protocol in Classic platform as part of the R25-11 release. The main topic is the introduction of the service-oriented architecture. The first slide shows the agenda with the list of the all covered topics in my presentation. But first of all, I would like to start with the theme. Yes, the team that worked on this project in this year and part of last year. Huawei worked as the concept leader and the major contributor for that. The other partners are RTI and the three Chinese companies, Reach Auto, Joinex, and iSoft. We worked even with ABI system that completed the validation work for part 1 in the previous R24-11 release. That's the thing. Next slide show a little bit an history of the DDS in AUTOSAR Classic platform. As shown, it was necessary to divide the work into several phases. The complexity of the topic is mainly due to the intrinsic mid-level nature of the DDS, which had a significant impact on many layers of all the AUTOSAR stack. We introduced the DDS BSW module in release 22.11, providing the basic data-oriented communication functionality in a full static configuration. In the next release, the R23-11, we added even the system configuration, which is essential to enable practical use of the module in a real-world scenarios. And finally, the current release. The current release closes the concept and introduces the service-oriented architecture. They also call it SOA. In a full dynamic configuration that rely on two different sets of discovery protocols coming from the OMG standard and directly from AUTOSAR adaptive platform implementing and compliant with service discovery. Let's start now with the first technical slide where we show what we mean when we are speaking about SOA in AUTOSAR. We don't want, of course, to go in deep, but we assume that the rough meaning of service is already known. We only would like to show the main objects that are important to understand how the service has been modeled with DDS. We have the basic object, the service interface that represents the contract, the object defining the type, the format of information that is exchanged between a service consumer and the service provider. Then we have the service instance that basically is synonymous with service, and it refers to a concrete implementation of a service interface. Finally, probably the most important object for us, that is the service instance element. This is a component of a service interface representing a specific communication paradigm, like an event, a method, or a fields. Usually, a service interface is composed of multiple service interface elements. In AUTOSAR Adaptive, SOA is implemented through both DDS and SAMIP. While in Classic platform, up to now, SOA was supported exclusively by via SAMIP. But starting from the current release, DDS will also available in the Classic platform as a valid alternative to the SAMIP protocol implementation. Next slide is probably the most important one in my presentation. Yes, because it shows the two fundamental mappings between the three levels of abstraction that we use to model a single service interface element. On the left, we can see the set of different types of service interface elements, each corresponding to a specific functional communication paradigm. This model forms the basis of the most abstract definition of service, and it is applicable to both AP and CP. In the center, we see how each service interface element is modeled in Classic using the three well-known communication interface types: the sender receiver, the client server, and trigger interfaces. This is already known as a way to model this kind of element in AutoSAR Classic platform. And finally, the new. On the right, we see the typical DDS functional blocks that have been used to model the generic service interface element. So, we can conclude that a direct mapping can be established between the functional representation and its implementation using DDS object on the right. For example, for instance, a method based on a request response paradigm, also called the RPC, can be implemented using a pair of data writer and data reader object, both on the server and client side. This led to an extension of the DDS model at SUC level, with the introduction of at least one of these new objects representing the generic service interface element. Now, first, to show all the changes, we would like to list all the functionalities and changes that have been introduced in this release. First of all, the SUC DDS model has been heavily extended to support the new SOA capabilities. We introduced the DDS transformer in BSW, and we added the discovery capabilities directly to the DDS BSW module. It supports DDS OMG simple participant and simple endpoint discovery protocol coming directly from OMG standard. Then, as we already said, the service discovery protocol compliant with DDS in AutoSAR adaptive platform implementation. We added a significant impact on system level model. Yes, because we extended the DDS service classes and we did a huge refactorings of them. Of course, due to time constraints, only a brief overview of some key aspects of each functionalities will be shown in this presentation. But at the end, we'll take a look to a specific case study. Okay, this is the architecture. First of all, we have to see how the architecture has evolved from previous release to current release. Basically, we see that two major differences can be observed. The introduction of a new module called DDS-XF on the left, that is the new architecture, on the right. And a new interface available to the DDS module to have a direct interaction with socket adapter connection. DDS-XF is the DDS format that is responsible for properly formatting the application PDU containing the input data, while the new interface with socket adapter is required for the dynamic configuration of the remote node addresses that has been got through the discovery procedure. Basically, this is the same requirement that is posed by SAMIP. In that case, it is addressed through a similar interface using the SAMIP service discovery module. Next slide shows an example. The modification we introduced in the SUC model related to a specific service interface element, the request response method. Let's ignore, of course, the complexity of the formalism of the UM model, and let's try to see how the schema reflects the two theoretical mappings shown in the previous slide. There are some key points. First of all, we see in red circle number 1, the introduction of the service instance object at SUC level. Until now, it exists only at system description level. Of course, the SUC level object is directly derived from its counterpart at the system level. In the red circle 2, we identify the modeled element. We have it is represented by an object named DDS service methods request reply methods. And the most important thing to note is that it includes a reference tagged as client server operation. It's indicated the port interface being used. Finally, box 4 shows how the object is linked to a data writer and a data reader object. Those names should be familiar to who knows the DDS protocol. Then the transformer. Next, this slide gives a brief overview about what's the role of the DDS transformer we saw in the new architecture. First of all, this is a serializer class transformer, and this kind of transformer is almost always required when formatting a PDU to pass the PDU router. Handling of a client-server interface needed to manage SOA has made this necessary in line with the typical approach of AutoSAR Classic. In AutoSAR Classic, SAMI PXF transformer already exists. It is similar, yes, but there are some differences. Both are serializer transformer and both are stateless. But unlike SAMI PXF, DDS-XF does not require any specific extension to the model and does not define any network protocol. Basically, the DDS transformer performs a simple copy of the data and operation parameters from RTE to PDU and vice versa. Of course, this is a new module, so a new specification document has been introduced. This slide summarizes finally the key point of the important dynamic discovery capability, the so-called discovery engine. SOA and discovery are independent, yes, but in practice, the discovery procedure becomes essential for the use of SOA. As I already said, two types of discovery has been introduced, the two standard OMG protocol, the simple participant and endpoint discovery protocol, and the service discovery protocol in accordance with the AutoSAR adaptive specification. And based on whether or not these kind of mechanisms are enabled, we can have three different network scenarios. A fully dynamic network where remote nodes are unknowns and they are discovered first through SPDP and then through SEDP. This represents an example of two layers of discovery. The intermediate case is a partial dynamic network where remote nodes are known, but the endpoints not. And finally, a completely static network where everything is predefined in the configuration. Yes, it is important to note that all these kind of tree discovery features are implemented entirely by the DDS model, and they start after the initialization of the model without any application level control. For instance, by the BSW module manager, which basically is what is instead expected in SAMI-P architecture. The discovery engine works finally as a background process and becomes active when a remote node has been updated, and it becomes a necessary update in local connection with the new added interface. This slide is the last slide of this brief walkthrough about the work done in DDS. And it shows the job, the work we we did at system description level. Basically, the DDS model at system description level is based on the SOA object service instance. And as already mentioned, it was introduced in R25-11 release. In this release, we reworked these classes and we added new requirement constraint in a similar way how it was already done for some EP configuration. I would not to go into further detail on this part. For those interested people, I am fully available via chat and via mail, of course. We would only point out that while the DDS SOA system configuration is complete in this release, the discovery part is still under development and will be probably handled in the next release. Let's start now with a quick show of use cases. In this slide, let's try to see a network behavior, a journey of a method request between two different ECUs. On the left, we see the client, and on the right, we see the server side. Here, we see the generation of a client request starting from the application software component. Then we see now the transformers that formats the application code PDU, and the red circle to show the details of the new PDU, either the infrastructure of either that worked by transformer after transformation. The application core PDU is handled by the DDS logic that is mapped to an RTPS core PDU and sent through the network. On server side, we see this kind of received RTPS core PDU that is processed by the DDS instance on server side and passed to the inverse DDS transformation function at RT level. Then the application software component, the application server software component process the request and produce a response. This response will be processed by the DDS transformer on server side and maps to a new application red PDU that will be sent as a response RTPS PDU and received by the client side. In client side, we have the inverse transformation that produces an application red PDU, and finally, this application PDU will be the payload will be processed by the client application as the response of the entire procedure. That's all for this release. Now we can simply see that there are at least two additional topics that could be addressed in the next release. The system model for discovery must be completed to enable a direct derivation of the configuration. And the introduction of the new interface to control the service through the BSW module manager. This is under evaluation and may be considered as a reasonable addition. So thank you. That's all I completed, and now I would like to hand over to next presenter, that is Christophe.